Okay, so I have 10 minutes to, and I'm the fourth ladies of the panel. I was told that a similar panel was held a while ago, and I'm replacing a man. So. Okay, so I will talk about my experience with INEX. And Noriko and myself worked on INEX from 2002, and 2007 we stepped down. And it was really nice to hear Jaap talking about the recent development of INEX. They took my baby and they're doing a good job with it, so I'm happy. So I will describe a bit my one of the main issues that I account with INEX, and I think some of the people working in it will smile, is we were dreaming about metrics. And I will explain why. And something which I think we didn't do too well, and I'm happy to take full responsibility, we messed up with the structure. Okay, so I will describe this and give you an example, a bit rather concrete, but to show the fun that you do trying to organize an evaluation initiative, the hard work, and something which I found was great is the collaboration with people, and especially if you organize a workshop in Dax tool, and there's a seller at the end, which always helps the collaboration aspect. Okay, so very briefly, what XML retrieval is about is you have some sort of text document that has most, in our case, organized into a logical structure. You have book made of chapters, chapters made of section, and so on. So when the user has a query, you do not know beforehand what is the best element to return. It can be the whole book, or it can be a section or subsections. And there's some sort of dependency between retrieval in the sense that if a section is actually relevant to the query posed by the user, it could be that actually the chapter is also relevant because the chapter contains that section and so on. So the aim of XML retrieval was not just to find relevant document, relevant elements, but elements at the right level of granularity. Of course, it's easy to always return the book, but we wanted to really return the most precise information to the user. So our principle when we started is this idea of returning the most specific parts, in our case, XML elements. So we use the logical structure that come with the XML markup to decide what to return. And just as an example, football. So imagine you have a chapter made of 2 sections. It's a very simplistic example, okay? And the first section is about history, and the second is about football and regulation. Of course, the whole chapter is going to be about football, but if you want to do what we thought was the aim of XML retrieval, is we should actually return the section because it is relevant. The chapter is also relevant, but it's more focused to what the user is looking for. So that's the general principle. So then we have to look, okay, so what is relevance in XML retrieval? So if you read an article about the issue of relevance, at least in the context of evaluation, to make it possible to compare system, some assumption I made that it is respect to the topicality, often the binary relevance is used, and the relevance of a document is independent on the relevance of another document. This does not hold in the context of XML retrieval because if you have a section that is relevant, the chapter, for example, containing that section is also relevant. One may be more relevant to the other, so we already need something more than the binary relevance. So just saying that something is relevant is not enough. So we had to extend the definition of relevance to capture the notion of specificity. How specific is this answer to the user in a sense? Okay, it is relevant, but it only discusses what the user is looking for. So now when you do this, you have this notion, again, going to relevance is propagating. So if this is relevant, this is also going to be relevant, and this is also going to be relevant. If you use a non-binary relevance assessment, you will have various degrees and so on. So in the INEX collection, for example, in 2004, we have, for example, 26,000 relevant elements, and often they appear across a path. So what do you do with this? What happens is when you build your QREL, you have a lot of overlapping elements, nested elements. So when you build your QRL, you will have this and this. Those are elements. They're actually related to each other because they're among the same path. So we have this QRL, and then let's do standard precision and recall. So well, that's not me who did it. It's actually Benjamin Piwarski and Patrick Gallineri at that time at the LEP6. They do some simulated run. They simulated the best. Sorry. So this is a perfect run, which ran a little bit like this. And then they add the parent. So the perfect run will be made of elements, and then they add the parent of those elements into the retrieval result, and then they get this one, the second one up. The mouse is gone. I tend to destroy technology, so I did this in Russia actually. Okay, so this is the perfect run. You add the parent element, you get improvement in performance. You add then even one element above the parent, you get further improvement. And if you add all the ancestor of that element in your retrieval result, you get much better performance. And the idea of XML retrieval was to do focus retrieval. It was really to retrieve the perfect runs. I'll skip this. So what do? So we have this problem because we needed to consider the fact that elements overlap. So one solution will be, well, let's just have in your relevance assessment the perfect element that every system should retrieve so there's no overlaps. But if you do this, you have this other problem is the evaluation become too strict. So XML retrieval is not just about querying, but when you return an element, in principle, you will develop an associated interface where the user can browse up and down that element. So even if you know what should be the best element to return, it could be that your system return an element at the higher level or at the lower level. Those are what we call near misses. So they're not the best element to return, but systems that return those elements should be still somewhat rewarded, for example, in terms of precision and recall, in a way so that they are still shown to perform better than compared to systems that return nothing along, for example, a relevant path. So it was not just the solution, let's just try to find what are the really best elements to return. We needed to consider the amount of overlap in the result. So as a result, people that participated in INEX got very much excited about actually the evaluation methodology, and a lot of people actually propose metrics. I think it must be the only initiative that have so many proposals of metrics, which were often debated at the workshop, and they were fierce but friendly debate. I think I'm right to say that, yeah? Yeah, and the good thing is at the end, Norbert and I could decide what we wanted, so we let the people fighting and then we decided. And it was great, and so on. So there have been a succession of metrics, and at the end, just to show what was the problem. So in 2004, where we were not really so aware of, we need to measure things properly. And in fact, we did it wrongly for a number of years. And so, for example, these were the top performing run at INEX 2004. And those are the average precision using, in a way, standard way to do like this. It was not mapped, but it's not unrelated. So those are the top performing. And in the blue thing, you see the amount of overlap. So those are nested elements they have in the result. 80% overlap. It means a high number of redundant information is returned to the user. Then Gabriela Kazai she was doing her PhD on proposing another metric, and I'm not going to give you the detail, but just to show how things work, based on a DCG. So those were the same run, where she applied her metric, and you can see. So those are the ranking, and between the brackets, for example, is how those were evaluated using the normal standard procedure. So a complete radical reordering of the system. So it's just to show that you can get it wrong if you're not too sure what you're actually evaluating. So you see the first three were actually systems that didn't return overlap. They were trying to do what we wanted XML retrieval system to be about, focus retrieval. And they performed very badly with the way we were evaluating XML retrieval in the beginning and so on. So it's been somewhat solved to some extent, although what we're using now, and I believe it's still used, yeah, you haven't made any change. No, we left and it has problems like tiny. But so what now they're using is still precision and recall, but based on what is called amount of relevant information. So the way the assessment is done is you show a document to the user and you ask the user to highlight what is relevant to a particular topic. So then precision, yeah, so this is precision at a certain rank. You look at the size of all the retrieved elements, and you look among those the size of highlighted content in those elements. So instead of counting the number of elements, we look at the number of highlighted character. And recall is defined similarly. You look into the test collection, you look at the, for example, number of character highlighted for that topic, and then you look at how much of it has been retrieved up to rank R. And this is still the state of the art now in INEX. So this is just to illustrate the fun. And it was fun, but it was hard, and it took us a while to get it right. And we got it right, actually, but by working together, which I thought that was great. Now, what I think I kind of messed up is the structure. So, in INEX, the impact of the structural constraints. So the whole point is to be, in principle, able to submit query to a system where you can express structural constraint. So this would be, for example, a query, like the title query, and then you decide upon looking at your result that a better query where you give information about where the relevant information is to pose some structural constraints. And it didn't work. So by posing a more precise query, we didn't improve retrieval performance apart at very, very high, very high rank. And why it didn't work is because we did something wrong. And I'm glad to see that it is changing. Was it the document collection? We use a typical logical structure, so maybe the XML markup doesn't matter so much. It's actually the query. The query were not structural constraints. They were not real query. The type of query was retrieve article or body, or section or subsection, or paragraph. So we were doing passage retrieval, or we were doing size-based retrieval, or just document retrieval. We were not actually posing real structural query. And the relevance assessment were at the content level. So when we asked people to assess the assessment, to assess the relevance, we asked them to ignore the structure, just to look at the content. And I did think that maybe we should have asked a bit more, but because we got the query wrong, I think this has been, the problem. So, and just to finish, to continue what Ricardo was saying earlier, so there is this work on science of user engagement. So actually, I will be returning full to evaluation because I will be spending some time in Barcelona to work on the science of user engagement. Okay, I'm done.